Hello, good morning, everyone. My name is David. I would like to thank the organizer and all professors to join us and even in the website friends. And I would like to share my recent works. I come from NCHU, and here is my study topics. I focus on my background is chemical engineering. So some of the idea is like engineer background and focus on two projects. The basic research is about cancer research. I would like to share you some of my ideas. And the second one is about regeneration medicine. So we hope can regenerate some organ, bone, skin, and others. Here is my group and something else. And three topics I would like to share. And maybe there is still a little time I can share about some business cooperation. The first one is about cancer research. And this is the background, as you know. In about half century years ago, we have chemotherapy. And about 20 years ago, we have target therapy. Especially, we may know the immunotherapy right now still a superstar, but all kinds of therapy of cancer still have very, very strong side effects. So the patient still can hold it. The problem is not we cannot kill cancers. It's the problem we can kill the cancers and meanwhile make the people or patient still alive. So that is the problem. And my focus is about melanoma. It's a very, very bad cancer cell, a skin cancer cell. Then you can see the development and something of the background. And I would like to show you, this is the clinical right now, the drugs for chemotherapy, including target therapy on your left-hand side. And on your right-hand side is the immunotherapy. And both drugs still have strong side effects to the patients. So this is what we want to solve it. Okay, I would like to share you about immunotherapy once again. Even the Nobel Prize owners still announce the drug response still have very, very low percent. And the price is very high. Even right now, 健保局 still can hold some funding for this, but this is still very, very expensive treatment. So in here, the first therapy of my study is we collaborate with optometrists and then we purified a natural compound from lotus and just we can eat day by day. So it's very easy to get it. And I will make it quickly, so we will focus on the conclusion directly. This is a new compound, sorry, over there. This is over here. This is a new compound structural name and can induce two pathways. The first one is autophagy, and the second one is apoptosis in sequence. So give me a hint. A compound induce two pathways. So maybe patients got very, very strong side effects because this compound or this small molecule cannot recognize cancer cell and the normal cell. Very, very, very smartly. As you know, in fact, all the cells from the same of the unique patient is quite similar. Usually it's gene a difference amount or protein difference amount, just that. So right now, we are not focused on one gene or one protein anymore. We try to focus on protein-protein interaction inhibition. So for this example, we choose stage 3 as our target protein. And this is a homodimer. And also a transcription factor. So once cell want to get some proliferation, and this protein will combine together, become a dimer, then enter into nucleus by DNA, then cell grow up and proliferation. So we just stop the combination. Okay, here's the idea. And then this is another one. We choose BRD4. This is another protein and also a transcription factor. So once again, maybe small molecule or other immunotherapy or like radiation therapy side effects is very, very strong because one gene, one protein, even big pharmaceutical company, they want to figure out the pathway. However, cancer cell is very similar to normal cell. So usually patient will lose hair and the snail died or something else. But if we choose protein-protein interaction, individual protein activity or function, we didn't affect that. We just stop the interaction when they combine together. Okay, we choose last rough. Sorry, can show in the side. Sorry. And we enter NCHU and we choose P53 and S100B. S100B is a very unique protein in skin, especially in melanocyte. So melanoma also can be infected. And we focus on another P53 and you can see and the P38. So all the protein-protein interaction. Okay, I will go to the conclusion in the cancer part. So we can detect, sorry, I don't have time to show you microfluidics, and we want to apply a new strategy, not only, thank you, not only just one gene or one protein. And then another one is biomaterials. We can synthesize biomaterials and for the regeneration medicine. And this is the background, so you can see we just need skin. And we have cells through stem cells, no matter the types, and we can create synthesis biomaterials and in fact stimulate the microenvironment. And this is the basic idea. And you can see this is biodegradable. So original without cell, and this is with the cell. So you can see the fracture and very, very small pores because digested by cells. And this is the carton map for the conclusion. You can see easily together. And we can see this is biomaterial scaffold and co-culture with stem cells and screen out the growth factors and enhance wood repairing. And we also create a new strategy of PRP, pattern-rich plasma. So we can get lots of, this is the protocol, lots of growth factors. And these growth factors help patient to repair their wood. This is for the stem cell and the clinical side. And sorry, I think I don't have time. I will make it quickly. This is a small project, and we have a competition in Paris and got a reward. I would like to move to, this is happening. Okay, sorry, sorry, time limitation issue. Yes, I have only 1 minute. About wood, there are several want to solve the pet infection and how to say that, and scar and something else. So we can try to, sorry, we can try to figure out, we can make the cell proliferation in the scaffold and no infection and no pain and no scar. And right now we try to figure out how to solve each. So here is the idea. Okay, list the animal. Okay, here is my idea. How to make this is a movie. Sorry, I don't know how to use it. Oh, thank you. 这个地方 Oh, wonderful. This is my PhD student. She can move and then you can follow because right now we don't want to sacrifice animals anymore. So for the wood, you may see redness, swallow, and the heat or warm, and the pet. So we can detect swallow color or something else. So for the inch also has this syndrome. So use AI so we don't need to sacrifice animals. Thank you. Actions.